I'm Mayfield. I'm a volunteer here at the museum. Helped out in the library and also helping out Bob downstairs in terrain restoration. I've also recently been selected as a new Solar System Ambassador for 2016. And I'm here presenting Lyford Rome. He's been here presenting at the Air and Space Museum. He's been at a few events here, and he's been a Solar System Ambassador since 2009. And did you guys hear me?
Can you all hear me, or should I use the microphone?
Use the microphone, please, otherwise I can't pick you up on the video.
All right.
The rare two-handed technique. Okay, so I am Lyford Rome. Thank you, Yvonne, for that introduction. I'm a Solar System Ambassador. Solar System Ambassador is a program from JPL. Today we'll be talking a little bit about the new versions of this, new understandings of the solar system. It's a somewhat controversial topic regarding a certain Pluto, but we'll get to that in just a little bit. I will start with a disclaimer. I'm an avid enthusiast in the planetary science realm. I'm not published, I'm not an astronomer, I'm an educator. I teach at Francis Parker School, which is just up the street a little bit in Linda Vista. I've been a Solar System Ambassador since 2009. Solar System Ambassador is a program to part of the outreach of JPL, Jet Propulsion Laboratory, and NASA to promote planetary science and awareness of different space missions. So there are several of us, actually quite a few of us, there's over 500 of us scattered through the country. We're almost like museum docents, but we're actually talking about space missions. So it's part of the Education and Public Outreach Office, which you all are probably intimately familiar with in terms of the Air and Space Museum. Well, this critter is probably one of the more famous stars right now of the Jet Propulsion Laboratory. Does anybody know which planet is this? This would be Mars. This is the Curiosity rover, also known as the selfie rover, likes taking pictures of itself. Curiosity is one of two rovers running on Mars right now. The other one is Opportunity, which doesn't have the same kind of articulation in its camera, so it can't take as cool selfies as Curiosity, but it can take a nice silhouette of itself in the shadow, and it can also do a top-down image. They do these images just to also look and see how well the solar panels are still behaving. As you know, that they're a solar-powered rover, whereas Curiosity is a nuclear-powered rover. Well, I'm not just here to talk about Mars. Humanity now has missions almost all over the solar system. I'm not going to go in detail of all of them, but just let you know that we've got quite a few of the bases covered, working with the Europeans and Japanese and Russians also have, and Indians also have missions out across the solar system. I'm a big fan of the robots, but I'm also a fan of human exploration, so we can all just get along hand in hand. Usually we send the robots out first because it's a lot easier to not have to send food and underwear and stuff like that with them. Yes. So robots tend to pave the way for our human exploration. Well, let's get right into the controversy. The solar system. It all starts with a very innocent little question called, how many planets are there? And throughout history, serious science has investigated this question, and even when I was a child, Ronald McDonald, in 1969, before the Happy Meal happened, they handed out these maps of outer space, and it was very informative, but it also included something in the far corner there that wouldn't necessarily be included recently, the planet Pluto. And I don't know if you remember this, but this is how I learned. My very educated mother just served us 9 pizzas. That's how I could remember Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto, the 9 planets of our solar system. Well, if you ask that question now, how many planets are there? The polite answer could be, it's complicated. We had 9, now there's 8, or what's going on? And it all kind of can be laid publicly, in terms of public awareness, at this fine young man's feet, Mr. Neil deGrasse Tyson. He was head of, and he continues to be head of the Hayden Planetarium in New York, and they redesigned their solar system exhibit, and excluded Pluto from the planet side of the fence and put them in another category called the Kuiper Belt objects. This caused quite a lot of controversy. Immediately the reaction came in, "Dear Mr. Tyson, I think Pluto is a planet. Why do you think Pluto is no longer a planet? I do not like your answer. Pluto is my favorite planet. You are going to have to take all of the books away and change them. Pluto is a planet. Your friend, Emerson York." And another one, "Dear scientist, what do you call Pluto if it is not a planet anymore? If you make it a planet again, all the science books will be right. Do people live on Pluto? If there are people who live on Pluto, they won't exist. Why can't a Pluto be a planet? It's small, doesn't mean that it doesn't have to be a planet anymore. Some people like Pluto. If it doesn't exist, then they don't have a favorite planet. Please write back, but not in cursive because I can't read in cursive. Your friend, Madeline Trost." Well, so how many planets are there? Now this is a trick question. Are there 5? Are there 9? Are there 8? Are there 18? Well, the answer depends on when you were asking that question, not whether it's 8:30 in the morning, but whether it's 5 BC or 1800. For example, the Romans knew of 5 planets: Mercury, Venus, Mars, Jupiter, and Saturn. The Earth was not considered a planet because the Earth was just the Earth. But that's because the Romans knew the planets because they looked up in the night sky. They were doing visible eye astronomy, naked eye astronomy. People use the Salian term, but they looked up in the night sky and noticed that some dots of light weren't exactly the same as others. For example, some lights would process across the night sky. That is, in every night coming along, they'd be in a different part of the sky. They'd move across the night sky. So this is the motion of Mars going from August 23rd, 2007 to April 28th, 2008. Taking a picture of the same area of the sky, Mars appears to move night from night. And in fact, that's where the word planets come from. It originally means wanderer, and because they wander through the constellations. Well, this led to reinforcing the idea in the Ptolemaic solar system that the Earth was in the center and everything goes around it. And the planets, the wanderers, had a special task for astronomers or astrologers back then. How do you explain that motion? And that retrograde motion, because it appears to move back and forth across the sky occasionally. And since circle is one of the most perfect forms in the universe, especially in Greek philosophy, they thought, well, it's a wheel within a wheel. It's a orbit of a circle with another circle superimposed upon it. This is the primordial spirograph theory of planetary motion. Well, the retrograde motion is described by the circle traveling along the circle. And notice how it mimics the path that would be seen across the sky. Well, this was accepted for quite some time. In fact, you can see this is a book from the 1500s. You can see that circle within a circle there. And the Ptolemaic system lasted for quite a while. But experimental science, starting with Galileo, started to call into question. For example, Galileo, once he had a telescope, could look more carefully at the planet Venus in the night sky. And he figured out, well, if it really was an orbit of a circle with a circle around it, the phases of Venus should look like this because it's in between the sun and us, and so the phases of Venus should look like that. But the phases of Venus look like this when you look at it through a telescope. And that observation does not match the theory. What it did point him in the direction of was that we both are circling the sun, and the sun is in the center of our solar system. The other thing that gave it away for Galileo was the fact that he discovered the moons of Jupiter, which were objects going around another object. So obviously the Earth wasn't the center of everything. So that meant that the planets now could be considered celestial bodies and not just heavenly objects. And in 1781, William Herschel discovered Uranus And also by then, the Earth was considered a planet. So our count is going up. And then in 1801, a monk named Giuseppe Piazzi discovered Ceres, which brought the total to 8 planets. Now we consider Ceres something else right now, but we'll get to that in a bit. After that, there was a whole slew of discoveries of these other planets: Pallas, Vesta, Juno, Etria, Hebe, Iris, Flora, Metis, which might not sound familiar to you. But the reason is, oh, and then Neptune was found in 1846. The reason is, these were all considered planets in the night sky. And by this time, there were actually 18 planets considered. And as they looked deeper and deeper in the sky, they discovered more and more objects there, which up to that point had been considered planets. Well, what the astronomers decided was there were just getting to be too many planets out there, and these objects like Ceres and Vesta were not actually the same as a planet. There's a new class of object out there called the asteroid. And now we all know the asteroid belt, which is in between Mars and Jupiter, but up until then, these had been considered planets, just like Jupiter. Now, asteroids, we've been visiting some asteroids. These are the comparative views of the different asteroids we visited. Vesta we just left a little while ago. We have a spacecraft that went from Vesta to Ceres. And asteroids, you can see, there's quite a few of them. So I'm so glad we didn't have to memorize all those names in grade school too. That we call is an asteroid belt, and the mass of all those objects adding up don't really add up. They're slightly less than a planet. But why am I talking about the asteroids when I'm really talking about Pluto? Well, when Pluto was discovered, it was a single object moving against a star field. And then in the 1990s, our telescopes got a little better, and we started to discover other objects beyond Pluto's orbit. So now we've discovered another belt called the Kuiper Belt, which lives out past Neptune. And this is the asteroid belt in the middle here, the orbits of Jupiter and Saturn. And Pluto's orbit and behavior in the object looks more like a Kuiper Belt object than it does like the other planets that are considered in the past. So just like how Ceres started out as a planet and ended up an asteroid, now Pluto started out as a planet and ended up as a Kuiper Belt object. These are what we call the Kuiper Belt objects, the 8 largest we know right now. They're also called trans-Neptunian objects, which doesn't sound as euphonious on the ears. But we have Pluto and its moons, Eris, and it has a moon, Makemake, Haumea, Sedna, one that doesn't have a name yet, Quoryar, anybody want to try to pronounce that, and Orcus. And a lot of these are very diverse sounding names because we're not just drawing upon Greek and Roman mythology for names now. The International Astronomy Union, in a report in 2006, then decided to change the definition of a planet and to introduce a new category called a minor or dwarf planet, and then categorize everything else as small solar system bodies. So this is just changing the nomenclature. Pluto isn't actually, it doesn't care. It's just sitting out there, but we've decided that it's no longer a planet because it has no longer cleared its orbit. It's part of the Kuiper Belt, which means there's thousands of somewhat identical types of bodies out there. So that would make it a minor planet rather than a full-fledged planet like Jupiter, which kind of, nobody's going to argue with Jupiter. So again, we're just changing the name of what we're categorizing Pluto. So where does this leave us with our 9 pizzas? Well, our 9 pizzas have been split up into more varied categories that match what we see out there. And those categories are gas giant planets, terrestrial planets, dwarf planets, icy bodies, and small bodies. So, and a bunch of other stuff which fall under these small bodies. So this is our view. This is every object in the solar system to scale that's over 400 kilometers. So there's no discounting Jupiter. It kind of, in fact, some people have said the solar system is basically Jupiter and a few leftovers, because everything else really pales in comparison to it. Saturn, the Earth's up there. And then we have a whole set of other bodies down here, which are the Kuiper Belt objects and asteroids that are large enough. And you can see they really are much, much different class of object than the planets. These are, so far now, are non-planets that we've discovered and explored. And there's quite a few of them. Some of them would be planets if they weren't a moon. For example, Titan is a large enough object. It's one of the moons of Saturn, but it has an atmosphere. And that would, if it weren't orbiting Saturn, it would be considered a planet in its own right. These are some images now of all the missions we've landed on, starting with Earth. This is the surface of Earth. This is the surface of Titan, the moon of Saturn. This is the surface of Mars. Venus, we've had, the Russians have sent several landers to Venus. The moon, 1969, we all remember that. We've landed on asteroids. The Japanese, most recently, the asteroid Itokawa. And then the Europeans have just landed recently on a comet with the Rosetta mission. And so that last image is of a comet landing on the surface of a comet. The gas giants, obviously they're giant and they're made of gas. The terrestrial planets, Earth, Venus, Mercury, and Mars, are more rocky. They're the ones that kind of are lumped together, but they're the ones in our immediate neighborhood. Icy bodies are things like comets or some other moons that might be composed mostly of water ice or other ices. And here's that mission I was talking about. This is the Rosetta mission landing on comet 67P. This is a close-up of that comet. And comets can take very unique shapes because they actually evaporate as they, and sublimate as they get closer to the sun. So parts of it just cave away, as you can see some of the trails and the gases, off-gas from the comet. So you get some very unique shaped objects that are small solar system bodies because, again, they are changing as they move through the solar system.
Could I ask you a question?
Yes, please
about
do.
That mission, is the landing on the comet, is that lander officially dead or?
So that particular, the Philae lander, this little guy,
Yeah.
landed, it bounced too many times, it ended up in a shadow. They've recently been able to get its contact, it's phoned home again. So it actually, once the comet got closer to the sun, the solar power, the shadows changed, the solar power kind of woke it back up. I checked earlier in the week, they've been able to have contact with it, but they haven't actually pulled any serviceable data other than just, hello, I'm here, I'm working. So they're trying to get the orbiter to actually talk to the lander in a more sustained fashion to try to get more data.
That's what I heard.
So somebody else might have more recent information. Yeah.
Can you turn off another bank of lights?
Sure.
Because we're
Yeah,
not
we
seeing.
can now turn off this overhead, just be careful, but yeah, you'll still have down lights, so,
Okay.
yeah.
Yes.
I understand that gravity is related to
You got
mass, right?
Yes.
Okay, so the Earth has a certain gravity we call 1g. The Moon, being basically what 1/3 the size of us, has 1/3 the gravity.
1/6.
1/6. Okay, is that? And now, so when you get to something with a weird shape like the comet there, how do they gauge what the gravity is of that thing?
So that's a really good question. So the mass, they actually tell from the way the orbiter reacts going into orbit where the concentrations of mass are. They have estimates going into that. That was one of the problems designing the lander, because the lander is approaching at a speed and closing a distance, so it has its own momentum. And given we don't really know the composition of the surface, it could be like a dirty snowball, you might have heard that term, people describing comets. Or whether it's hard ice, trying to design a lander that could land in a soft snowbank or on hard ice would actually be tough because you don't really know what type of surface you were. So that's where it actually bounced, because the gravity is so light, even though they were successfully able to get towards the planet and account for the gravity and the rotation and everything like that. these irregularly shaped objects are very difficult to navigate around. Additionally, because you can see it's also shooting at you, as you know, that's gas, off-gassing and particles. So a sensitive scientific instrument wants to not get right. It wants to get close enough to sample, but it doesn't want to get close enough to get sandblasted. I'm exaggerating, but at these velocities, even small particles can cause damage.
How fast is it going?
I have to look that up. I haven't committed that to
The
memory.
lander, by the way, had spikes in it that were supposed to operate, but they didn't.
Right, so there was a harpoon system that was supposed to shoot into the whatever the soil was or the ground was, that actually was malfunctioned and didn't fire off. So when it landed, it just kind of bounced, which, given the real lightness of the gravity, was inevitable.
So is the tail ice?
The tail coming off is off-gassing, so it's water sublimated different gases. So it's not necessarily like chunks of ice breaking off and particles that way, like ice cubes, but it'd be the evaporation of whatever constitutes the comet then sublimates out into because of the heat of the sun. So those are ionized particles. Those are particles, but they're not like chunks like rocks or something, or snowballs coming at them.
And do they go away from the sun? Not necessarily.
Yes, that's correct. So they would be in pointing away from the sun. And there's a very interesting comet that was just visiting us a couple weeks ago. It may be beyond visibility now, but the way the actual shape of the comet, it actually has two tails, one perpendicular and one actually in its line. So it's just the way the physics of the particular comet breaks apart and off gases.
So some of the orbiter is still working because they were concerned about the particles hitting the orbiter.
That's correct. So the orbiter is still working, and it has been working. That's the part that stays orbiting the comet. And it should still riding along with the comet as it goes through around the sun. Well, the current understanding is that most of the comets come from something called the Oort cloud, which is way out from the sun. And this is a logarithmic scale, so you can see it's actually very, very distant. So some comets come in and visit us, and then they come back in like 76 years. They have a period of 76 years, like Halley's Comet. Others comets, you may get one chance to see it, and it'll be gone before we get it. So this is an interesting video. This is where it's very dark, but this is a video of the discovery of all the asteroids that we know of and near-Earth objects. This is, the year is down here. It starts at 1980. And this is called what we call a sky survey. So different groups will get funded just to look in the sky and see what they can see that hasn't been discovered before. And you can see Earth, there's the sun here, we got Mercury, Venus, Earth, and Earth is pointing out, looking at, you can see as things get lit up. So in the beginning, we didn't have very many, all the major asteroids have been found, but the search has intensified recently because there's a real danger of an asteroid becoming a near-Earth object, and a near-Earth object has the danger of becoming a very near-Earth object, which is something that we don't really want to see. So we can't see what's going to hit us if we don't actually look at what's out there. Very quickly, you can see every year more come online until there's hundreds and thousands of them. And in fact, now it's gotten to the point where people can name, astronomers can name the asteroid after a particular celebrity or something. So there's a George Sulu asteroid and a Leonard Nimoy asteroid, and probably many other ones. This is up to 1994.
Shouldn't we stop looking for them if they're just going to keep coming?
Yeah, I know. Well, that's the old, well, not the old joke, but one of the jokes is that the difference between humans and the dinosaurs is that the humans have a space program, and so we can probably intercept one of these if Bruce Willis is happy to fly this shuttle again. But let me fast forward just a little bit if I could. Oh. You're going to see eventually this whole belt fills up. And those that are green, the ones that are now, some funding must have just happened because now they're really going. And notice it happens in a pattern because it's in direct opposition to where the sun is. So that's how they're finding them when they're doing an optical survey. They need that part of the sky illuminated.
What's doing the looking?
Just grad students and different. No, I mean this is the sky survey is done by several different observatories and telescopes outside.
Are all these different belts, the Kuiper Belt and this belt, are they basically on the same plane as our orbit?
Yes, that's a very good question. So yes, this right now there are objects within it that are not, but for most intents and purposes, most of the objects in the solar system are along the same ecliptic plane, the same
Green, is that
plane.
the type?
This is all the asteroid belt still.
All of them?
Yeah, and the ones that are red are ones that are Earth orbit crossing. So those are the ones that are we want to worry about. And we're only up to 2010 right now. So now obviously this is not to scale in terms of the density of the pixels, because space is called space because it's mostly space, and but stuff is out there and it's not that dense. So when you see the Millennium Falcon zooming through a asteroid belt and you're trying to zig and zag from hitting all the other bumper cars, that's not really accurate. But the idea is that all those things are in orbit, and as they interact with each other, some of them can leave their orbits and start crossing Earth's orbit, which would not be a nice day. Yes.
Last year I interviewed Rusty Swikert, who was in charge involved with this thing he called Project B612,
right,
which is trying to identify all the asteroids that could hit us. He said that they think they've found all the ones that are Earth killers, but there's thousands of city killers out there.
That's correct.
And then the other thing he said, which was impressive to me, is the fact that the Earth is going 60,000 miles an hour. So if we hit anything, it's a problem.
Right, and all those velocities are relative to each other. So that's something that is very difficult. So you might have a very dense asteroid that may be smaller, but it can survive all the way through the atmosphere and cause a problem if it actually impacts Earth. There are classifications, yet another level of classification. As you mentioned, there are planet killers, there are civilization killers, there are city killers. These are basically the size of the impactor that comes along. And there are theories that say the moon was formed by a giant collision with the Earth that actually tore the Earth asunder and caused it into two bodies. So that stuff actually happens. In fact, that's how a lot of these planets formed in the first place, because they're accrual of a lot of smaller collisions that come together. Well, the new category that Pluto got put into was called dwarf planets. And notice dwarf planets all are round, so they have something called homeostatic equilibrium, where they've compressed enough that they actually take a round shape, but they are small. So, for example, here's Mercury, Mars, Earth's moon, Ceres and Vesta. These are the two largest asteroids, but now they're considered dwarf planets. To compare, here's what Pluto looks like compared to Vesta and Ceres. Eros is another asteroid. You can see it's very small there. Charon or Charon is Pluto's moon. In fact, Charon and Charon are really a dual planet system, because they orbit, but they actually orbit a point in between. So it is not just Charon orbiting Pluto, they both orbit a center point of the center of their gravity. So just in case you're wondering, that's Pluto and Charon here. So you can see why it's called a minor or dwarf planet, because it's round enough to have the shape look like a planet, but in terms of comparing it to one of the terrestrial planets, it's actually very, very small. So right now NASA has some missions to the dwarf planets. Dawn is an ion-powered spacecraft that left Vesta a couple of years ago. Vesta is it's still kind of wobbly shaped, but it's the second largest asteroid. And you can see, speaking of collisions, every time you see a crater, that means something's bumped into it. So even in the asteroid belt, things get a little bit pockmarked. It then left Vesta and went to Ceres, which was, back in the 1800s, was considered a planet just like Pluto. And Ceres is much rounder. It's currently in a science mapping orbit of Ceres, and the thing that's caught everybody's attention are these two bright spots. Currently, there are several different theories of ice compositions or reflecting of just light matter. But I think NASA can safely say that it's not an alien civilization trying to contact us. So this is the dwarf planet Ceres, the largest of the asteroids. And New Horizons is now visiting the other demoted planet to dwarf planet, Pluto. It flew past in July. It took 9 years to get to Pluto, and it was kind of what we call a beeline mission, so it was the fastest spacecraft that humans have ever launched. It passed the orbit of the moon in 9 hours. That's how fast it was going. It got to the moon in 9 hours, but it still took 9 years to get to Pluto, even with a gravity assist from Jupiter. So before New Horizons, these were the best pictures we had of Pluto from Hubble. And there are a couple pixels, and some people did some very interesting experiments and visual imagery analysis that came up with some clues, but really they're just points of light. And distinguishing Pluto and Charon and then finding other satellites around it was one of the Hubble's jobs before New Horizons got there, because they wanted to make sure it wasn't going to bump into something that they hadn't discovered yet. And so there were several other satellites, moons of Pluto, that Hubble found, called Nix and Hydra, and then other ones that didn't have the name yet, P5 and P4. So basically New Horizons had to fly a straight line down the middle of this target without bumping into anything, but still getting close enough to take pictures. And here is one of the first images New Horizons did on approach. And you can see Pluto is no longer a pixel, it's a nice, well, dwarf planet. It looks very dwarf planet-y. This is now the trajectory it took, flying down the middle, making sure not to bump into any of the moons. And you can see it comes in very close, takes images, waits for the sun, so do some occultation experiments where they can see the limb and see if there's any atmosphere, and then flies off. And people ask, why didn't it go into orbit? If you're going to take all that time and just do a very quick encounter, it's because it's just going too fast, it can't slow down and stop, and it doesn't have, it has so much momentum, it would need a rocket the size of the rocket that launched it attached to New Horizons to then slow it down and put it into a parking orbit. One interesting thing is you can kind of see here, Pluto and Charon are actually orbiting a central point between them, because that's the center of mass that they're actually sharing. So Pluto then became a real world to us in July, as opposed to just a few dots. And people have noticed the different terrain. A lot of folks were expecting it just to be this dull, ice, dead world. But what really amazed some folks was that the variety of the terrain. And the variety of the terrain means that there's geologic processes, active geology going on this planet. So it's not just a smooth ice ball. There's mountain ranges and there's transitions between different geographic areas. In fact, there's some very complicated terrain that we still don't fully understand how it actually got. One of the moons of Neptune, Triton, has similar features like this. This is called the cantaloupe terrain, or the melon rind view, and that lends credence to the idea that the Triton, a moon of Neptune, is actually a captured Kuiper Belt object too. That's not actually a moon formed at the same time.
That's no moon?
That's no moon. It's a Kuiper Belt object. Here's a nice close-up of what some of the terrain transitions look. So we go from mountains, hold on, if you get vertigo, to plain areas, and some of these weird crack or fissure-like features. Here's a nice close-up of flying over Pluto. So I would not want to be the project manager in charge of the imaging routines for this mission, because you get basically, several hours after 9 years to make sure your cameras are pointed in the right direction and make sure you carry that one.
Is this
this color or black and white?
This is a black and white image. So I've got a colored one later on. So on some of these missions, they will send, the cameras are really data instruments, and pictures are data. So a lot of them will use a black and white high density imager, and then use color filters later on to take the image. So they're not just doing a point and shoot 3-color RGB camera out there to take, so they want those pixels to be. So color images are usually assembled after the fact. So this image was taken in black and white, but this one now uses color information from another instrument. So you can see it's kind of a brownish, bluish tinge, depending on the composition of the surface. I just want to show you this next part. This shows how close the wide-angle camera then compared to where they actually did the high-res camera, and now we switch to black and white. So you can see we can get down to objects that are only a few miles across. I don't know if you need to upgrade the flight sim background.
Yes.
Fly Pluto. And then there's that cantaloupe, that weird terrain. So what, and this I'm getting vertigo just now watching this, but Pluto is a living world, whether or not it's considered a planet by planet circumstances, planet criteria. Here's a little quick shot of the timeline and the bullseye that New Horizons had to fit. It's approaching, and it's only a few hours it does the full pass, and you can see, if we have time, I can show you a simulation of it flying with all the cameras. And yet it returned great images like this. There you can start seeing the atmosphere of Pluto, and that occultation experiment, when they flew away and it had Pluto blocking the sun, that's when the cameras could take images of the atmosphere.
Did they do that spectrographically?
Yes, I didn't put those pictures in the slide, but there are plenty of instruments that were sampling it all along. In fact, that's where some of the color information can come from, them using those filters also to contribute to it. So this is just what happened this last year. Pluto went from a pixel to a dwarf planet, but you can see starting from 1 dot all the way to the highest resolution that we've had. So to me, I think this is the last chance we've had as a generation for a while, because we've run out of big bodies in the solar system to explore. The new worlds, even though there's thousands of them out there in the Kuiper Belt, this was kind of the last of my 9 pizzas that everybody remembers, and the one that we hadn't visited yet. So that mission of discovery has now happened, and the good work of finding out what's next comes to New Horizons. So you are here. So this is the inner solar system, asteroid belt, all the other thousands of little bodies out here. This is the trajectory of New Horizons, and it encountered Pluto, but remember, it can't stop because it's just got to keep going. So it's going right into the Kuiper Belt, and the task now is to try to find another object for it to explore. And the Hubble again rose to the challenge and found an object, primary target 1, moving back here. And this is the destination that New Horizons will try to reach. And here's a 3D view of its actual trajectory. Oops, sorry. Is that going to show? So, there we go. So there's a lot more than just 9 things in our solar system, no matter how you shake it. So New Horizons isn't the only spacecraft to leave our solar system. Pioneer 11, Pioneer 10, and Voyagers 1 and 2 have all bounced out, leaving the solar system. New Horizons is still just small potatoes here. And even though New Horizons was the fastest spacecraft launched from Earth, Voyager 2 got an extra bump from Saturn and Jupiter, so it's actually traveling faster now. than New Horizons is, so it will never catch up, New Horizons will never catch up with any of the other probes. But leaving the solar system starts us with another whole, what do you call a planet problem, because there are other missions like Kepler that are finding thousands and thousands and thousands of exoplanets, which are planets orbiting other stars. So I think we're just at the beginning of organizing the sock drawer, so to speak, of the planetary nomenclature. And as we investigate more and more, we will find out that life is really quite abundant. I mean, the universe is quite abundant. It doesn't fit into our categories. So, how many planets are there? Well, 8. But it's wonderfully complicated. These are all the objects in our solar system over 200 kilometers that we've discovered so far. And now we're back into our real planets. There's Venus, Earth, and these wouldn't fit. Neptune, Uranus, Saturn, Jupiter, and the Sun. A question?
When we sent the New Horizons past Pluto, was there enough gravity in that gravity well to deflect it at all?
I don't think they no, because in fact at that point the primary mission was to everything, any course of corrections were all designed to maximize the science of the encounter. Finding, you saw how many objects are out there, so the job then was like, well, worry about where we're going after this, and they have enough propellant to actually steer a little bit, but again, it has so much momentum they can't really do a gravity assist. And Pluto is so small too, it wouldn't provide that much of a boost, but that's a good question. Yes, sir?
Were they able to calculate the surface atmospheric pressure?
I believe some of that stuff is coming down the pipe now. I'll have to look up that. But I know that they were able to do some calculations on that. And in fact, that might have even been the footnote of that slide I could back and see. Yes, Francis?
I didn't know until I saw this that they had an occultation with Charon as well as Pluto. Did they see any residual atmosphere there as well? Or?
I don't think so. I don't know. I don't know the answer to that. I'll have to look that up. Again, I remind you I'm a high school enthusiast. Yeah.
I would
yes,
like to remind everyone, if you're ever in Flagstaff, even if you're going through Flagstaff, going someplace, you have to go to Lowell Observatory.
Yes.
It's like 1.25 miles out of town. And they have you can actually look at the comparator that they used to find Pluto, and they've got 2 glass plates there. It's a great, there's no excuse if you go to Flagstaff not to go to Lowell Observatory. 750. And they even open up the observatory at night if you'd like to look through the big telescope.
So everything that I've shared with you today is from NASA sites or NASA affiliated sites. Once again, these are all taxpayer funded missions, and one of the differences between, say, some of our European counterparts is that by law, NASA is required to actually put the actual data into something called a planetary data system, make it available to the public within 3 months of the close of the mission. And that's intended to allow everyone to have a chance to investigate and look at the results. But it also is supposed to give the people who have dedicated their whole careers to these projects to have a chance to publish before some guy in mom's basement thinks of a new theory of everything. Yes?
Okay, I have an odd question. You showed us photos of these, and you ever been to a planetarium? They always show you photos of the Milky Way.
Yes.
How in the world do they get photos of the Milky Way?
So we can get, if we run back to the beginning of this guy, if we can see the Milky Way from the night sky. And so this is the photo of the Milky Way in terms of how we look at it from inside. And from doing the sky surveys and everything like that, they can reconstruct what the shape should be and then find another galaxy that might be representative, or else make a 3D model and then render it that looks like it. So it's not actually taken it's not an actual photo, it's a reconstruction.
Because a lot of them were in.
Right. So this is us looking into the Milky Way at night. Of course, unfortunately, San Diego is not blessed with dark skies unless you drive out to Palomar or farther than. Then our neighbor to the north tends to generate a lot of light pollution too. So it's very hard to see such a rich sky unless you're out where it's very, very dark. But back in the day, that's all you saw every night, you know, is the real rich night sky. Any other questions?
Wasn't there
Yes.
another way to memorize the planets, and something to do with Mary's violet eyes make John something?
That is not part of my folklore. I mean, if there are many mnemonics, I'm sure. Some of them may be saucier than others, but to help folks remember. But yes, and now all those, you know, we just have to end without Pluto. One of the other interesting things about Pluto is that when you had a question about the ecliptic and the plane, the Pluto is actually not in line as neatly with the rest of the planets in orbital inclination. That also lends credence to it's kind of come from outside. Yes. All right, well, thank you very much. I want to thank the Air and Space Museum and all of you for promoting.